All right, so in this video, we're going to talk about adding two different RGB values to each other. Like think about yourself adding two colors to each other. And I wrote one formula in the screen here. I wrote what happens when you add red, pure red, 100% saturated red, which is 255, 0, and 0, and add it to green, which is 0, 255, and 0. What is the result we're going to get? What color are we going to get? And what are the RGB numbers for it? And the math for that is really easy. You're going to take the red amount in both sides and add it to each other. So we started in red in 255, and on the other side red is 0. So when you add the two, that will give you 255. And then you do the same for the green amount. We have 0 here and we have 255. When you add the two, that will give you 255. And then for the blue, in both sides it was 0. So the adding of that will also result in 0. And this is the end result. That's the color you're going to get when you add red and green. So what color is that? That's yellow. All right, that's the color yellow. Now, keep in mind, we're not adding colors as in like we have physical tubes of colors that we're mixing on a canvas. We're not doing that. We're adding colors as in you have a ray of red light on your screen and you have a ray of green light on your screen. And these two rays of lights will intersect and they will produce a ray of light that is yellow. That would be the pixel that you're going to see on your screen that would be yellow. So let's actually prove that in the color picker. So if I go to my Photoshop document here, I have 255, 0, and 0, and I'm going to switch that to 0, 255, that's green, so you can see 0, 255, 0. But what if I add the two? What if I put 255, 255, and 0? The end result will be yellow. So yellow is the color you get when you add red and green. All right, if you add red and green, the end result will be yellow. While we're at it, let's look at the other pairs. All right, so what if I add green and blue? All right, so if I go and put maximum green and maximum blue, you're going to get this color. This color is called cyan. This color is called cyan. And then the last pair of colors is if I add red and blue. So if I go and make the red maximum and the blue maximum, you're going to get a color called magenta. All right, so if you remember, we started with yellow, and then cyan and magenta. And what we are adding is we are adding red and green and blue. Okay, now I'm going to go and write these in my notes because I think it's important to have a reference for that. And then we're going to discuss that a little bit more after the small pause when I write this. All right, so if we go to the second line, green and blue equals cyan, so 0, 255, 0, and 0, 0, 255. Again, we can add the amount of red separately. We can add the amount of green and blue, and that will give you cyan. And this is blue and red equals magenta. So I want you to notice on this side it says yellow, cyan, magenta. And then I want to remind you of something that we talked about briefly earlier, which is the two most important color modes, the color modes that you're going to most likely work with in graphic design is RGB, red, green, and blue, and CMYK. So I'm hoping by now you understand what these letters mean. They mean cyan, magenta, yellow, black. So if you are working primarily for print, if your products are mostly something that would be printed, you would be better off working in CMYK because all the printers print colors that are blended using a color component of cyan, magenta, yellow, and black. Basically, they are the physical cartridges of color that are existing in the printer, and the printer is adding them like over each area to give you the final mix of the color that you want. While if you work primarily with screens, like you're developing images that will show on a screen, on apps, on websites, then you're going to work in RGB color mode. Now, what if my work is going to be both? Like what if my work is going to be represented in both a screen and also in print? If you are in that particular case, the best approach is to try to figure out which one is more important of the two. And based on that, you can pick the color mode you're going to work with. So there's no clear-cut answer. A lot of professionals will give you different opinions. If somebody has a background of print, that person will say, of course, work in CMYK. If somebody has a background of web development, they will say RGB. It's really a matter of looking at the advantages and disadvantages of working with one of the two color modes and deciding which one you're going to work with in your image. In our class, we're working mainly in RGB color mode. That's the one we're working with. If you work in a studio, and most of the work is done for the web, then chances are it's going to be RGB as well. If you work in a studio and most of the work is done for print, it's going to be CMYK. Like the print resolution issue, when I told you always ask to verify, this is also something that might be a good idea to ask and verify. Whenever you work in a project, you might want to call the print shop, call your technical director at the company and say, just to confirm, the color mode I'm going to work with in that document should be this, and just verify that that info is correct before you proceed. All right, so now we looked at a few things. We understand what is a channel. We understand if I click cancel here, if I go to channels, we understand the red channel, grayscale image, from 0, no red, to white, 100% red. Here's the green, here's the blue. We understand why they are different, because they represent different values. We understand that what we are looking here at is the mix of all of them. We understand also something called saturation, which is based on the difference between the RGB values. We understand also what happens when we add colors to each other. So all of that is important. We can add one more little detail to this video before we go to the next point. All right, so that point is something called opposite colors, And I want to discuss this with you before I write anything. So I wrote here, the opposite color of red is what? What is the opposite color of red? And to figure that out, the answer is really simple. You're going to take the RGB numbers and inverse them. So whatever is 255 will become 0, so that will become here 0. And whatever is 0 will become 255. So if I go here and say 255, 255. Notice what I've done is I inversed the values. Whatever is 255 became 0. Whatever is 0 became 255. What is that color? We actually know what's that called. This is the cyan. So the opposite of red is cyan. Let's see if the logic makes sense. If you put the maximum amount of red and no green and no blue, that will give you red. But if you do the opposite, if you take away all the red and add green and blue to each other, we talked about that earlier. When you add green and blue to each other, that will give you what? That will give you cyan. So cyan is basically the exact opposite of red. Red is maximum red, no green and blue. Cyan is no red, all the green and blue. So that's one spatial relationship between them. Now, can you guess the opposite of green? What's the opposite of green? The opposite of green is magenta, if you guessed that correctly. And what is the opposite of blue? And the opposite of blue is yellow. All right, so let's see if that makes sense. This is the value for green. All right, this is the value for green, 0 red and 0 blue. This is the value for magenta, and that value is maximum red, maximum blue, and no green. So if I take the RGB values and copy them to add them here, here's the green RGB values, and here is the magenta RGB values. So now we can compare how they are exactly the opposite of each other. And if you do the same with the blue, we can copy that, and then we can go to the yellow, and we can copy that and paste it. And now you can see why these are the spatial relationships between these colors. So let me show you why this becomes important. For example, if we're color correcting something in Photoshop, I'm going to go back to my document here, and I'm going to create another adjustment layer that I showed you earlier. We're not really learning it, but just we're looking at it quickly to make sense of why we're learning all of that. If I go here to the levels adjustment layer, I mentioned earlier it will help you understand why we have 0 to 255 here. But if I go now and tweak just the red channel and go to this slider, which it's called gamma, we don't have to learn that again. Now there's a class in the future with all the details about this. But if I do this, notice I'm getting more red, all right? But if I do the opposite of that, I'm getting what opposite color? I'm getting cyan. So now we understand why cyan is appearing here, all right? If I redo this and go to the green channel, and if I do that, I'm gonna get more green. But if I move in the opposite direction, can you guess what color is going to appear? What's the opposite of green? Magenta. And if I redo this and go to blue and add blue, but if I go in the other direction, I'm going to get yellow. So that's the opposite color spatial relationship that we talked about: red versus cyan, green versus magenta, blue versus yellow. So when you work in Photoshop, it's important to know what colors to add that will give you a particular result, and what colors to subtract that will give you a particular result, or what colors are opposite to each other.